Good morning, everyone. Hope you're staying safe and healthy. It's good to see you again. Thanks for tuning in. Hoping you're having fun with the new task, weekly task. So again, tackle one at a time. That way you don't get overwhelmed. Here are some instructions. Not so much instructions, but they're kind of like notes in case you're having a lot of trouble with this task. Some what to do, not to do, what not to do, and so on and so forth. So continue having fun with it. Looking forward to what you produce. See you soon. Here's some instructions. And you click on open link. When you're working on these quizzes game, you can practice flashcards and go through the problems to for you to know how to tackle these problems, and then play the game. Play multiple times to get your best score. Click on the Desmos activity, open the link, and you don't have to type anything in. It should be able to ready to go, giving you the code. If you already signed in, then sign in again using the same name. Today's lesson is more of a challenge to see what you can think of. So there is no wrong answer. There is, but there isn't. So just do your best as you tackle these tasks. It's going to open up in the doc. I would suggest you can screenshot it. You can type one here. But to work it out and then explain what your thinking was on the Flipgrid. Here's what I have so far. I use Cornell Note format where you have the title. Today, these notes or these instructions can help you find missing sides of right triangles, or we can also call that a distance. So how can you find a missing distance using a right triangle? The first thing you should do is identify the right triangle. And I'm going to highlight the right triangle. There's the right angle. That means that it is the right triangle, so it can find the missing distance by using the Pythagorean theorem. So I need to label A, B, and C. I know A is the smaller side, B is the medium side, and C is always across from the right angle, or C is the longest side. They also call it the hypotenuse. Once I do that, then I can apply the Pythagorean theorem, which says that a squared plus the b squared should equal to the c squared. In other words, we don't know a, so we're going to leave it alone. This is looking very familiar. It seems like the one problem we had yesterday on yesterday's video. So I'm just multiplying the values by themselves. That's called squaring a number. If you notice, I just took 10 to the second power and I converted it into 100. So this should be 64. And then a is what we're looking for, so it should be a variable. The opposite of adding is actually subtracting because we're missing a or b. If you were missing c, then you would probably need to add, and then a squared, or the value, the a to the second power is the same as 36. Number to the second power is 36. Or we can do the inverse. The inverse of a square is the square root. So a is actually 6. So when you're doing your quizzes and this question pops up, you need to choose 6 because a equals 6. This also applies. Right triangles can be used to find any distance. So when you're going to see the same concept. Although it is asking us to learn about the distance formula. The distance formula is based on the Pythagorean theorem. So here's a line segment. It says to estimate the length of the line segment. In other words, how long is that segment? Since it is straightway, it's A or B of the right triangle. If this was the right triangle, then we can just count 1, 2, 3, and 4. So the distance of the line segment is 4. We don't have to put a unit because it's not asking for a unit. So that's how you can tackle this Desmos task. Here's another example from your thing to find the estimate. So you don't have to find the exact number, but I'm going to go ahead and show how to use the Pythagorean theorem to choose that, find the exact measurement. So first of all, identify the right triangle that you're working with. And this is how I see it. Other people will see it as a right triangle on the top, and that's also okay. Either way works. So I'm going to use this one since it's already drawn. So I know it's a right triangle. I know this is A. I know this is B. And in this case, we're looking for C. So A squared plus b squared should equal to c squared according to the Pythagorean theorem. We can't just count because the diagonal, it's the diagonal. You can't really count. So 1, 2, 3, 4. So a is 4 to the second power. B is actually 1, 2, 3, 4, 5, 6, 7, 8. 8 to the second power. And that should equal to c squared. That should be the estimated length of the segment given. And then solve for c. In other words, multiply, add, subtract, and find the Pythagorean theorem value of c. So 64, 70, 80. So 80 equal to c squared, which means we have to find c. So we have to square root both sides of the equation. So c is the square root of 80. C is equal to the square root of 80. The closest one that it's, closest square root is 81, and that's 9. So c must be 8.9 approximately. In this case, I would use the approximation symbol. So that's how you can estimate a segment. You use right triangles. You find the distance by using right triangles. So the approximate length is 8.9. And that's about it. Again, give math a chance. Continue keeping your brain involved. Have fun with it, and don't be afraid to reach out. Good day.